For real. That's how it works. All right, here we go. This is lesson 3.4 and 3.5 combined. We're going to zoom through this. So if you're taking notes, you better be ready and fast. Okay, so we know that sine and cosine are graphed by plotting the unit circle values. Yeah. Okay, so that's what's happening in this table. First off, we're plotting sine of theta as it relates to the unit circle values, starting with theta being pi over 6, which is here, right? If theta is pi over 6, that puts us in this triangle. Sine of pi over 6 is 1/2. So y'all fill this out right quick. I know you're bored already. We just started. Sine of pi over 3, that's a tall. So that's going to be square root 3 over 2. Okay, so move your way around this table. Y'all get them jotted down. OMG.
0. -1.
Okay, after you get them plotted in your table, plot them on the graph. And I believe that we can estimate square root 3 over 2 somewhere between 1/2 and 1.
French toast sounds so good right now.
Yeah. I'm in pretty good shape here. These are things that I do consider to be very important. That we understand that the midline is halfway between the maximum and the minimum values. The midline is halfway between the maximum and the minimum values. You're going to see, Passwater has a way of writing this that we've not seen before. Okay? So hone in on these details. This is going to be important. Amplitude is the distance from the midline to the maximum or the midline to the minimum. Remember that amplitude, we use absolute value. So even if I know the amplitude or the distance from the midline down is negative, I'm still going to use a positive number to represent amplitude. Period is supposed to be 2 pi on the parent function sine. So without any modifications, we expect to see a period of 2 pi. That is how long it takes to complete one cycle. That's what period answers. It's the length of a cycle. Versus frequency. Frequency says how many cycles can it complete in a certain period of time. Cycles per time. Okay, so period is time for a cycle. Frequency is the inverse of that, cycles per time. So you're going to be careful with that. And then we see that the sine of theta oscillates between concave down and concave up. It also oscillates between increasing and decreasing. Okay. Flip the page. Let's get cosine written out. It's much the same. Except this time, cosine of pi over 6 is my long, square root 3 over 2. And cosine of pi over 3 is the short, half. remember we graphed this the other day, and Joseph said, that looks really parabolic. It really shouldn't. It should look like your tails kind of fish out because they're ready to go again in the next wave of the cycle. Uh-huh. Okay, so again, with period, if you wanted to write that down, period is length of cycle. Period is length of cycle, where frequency is number of cycles per length. In physics, we learn that we measure period, we're usually in time. We measure period in seconds. So then we measure frequency in 1/, seconds, or seconds inverse. And actually, the unit that we use, second inverse, is hertz, which should make all kinds of sense to you music people. Frequency measured in hertz. Whoa. There it is. True, it's awake now. Pitch. Yeah, see?
They also
all right.
look like sound waves.
They are. These are sinusoidal functions. Okay, we learned that last week. Sinusoidal functions. Sine and cosine are both sinusoidal functions because cosine is just a phase shift of sine. If you move a sine curve pi/2 to the left, you get cosine. Okay, it's just a phase shift. Okay, so let's jump into example 1 here. That's all in the notes we need on that. Example 1, it says 2 periods of sinusoidal function f of theta are shown in the figure above. Find the period, the frequency, amplitude, and midline for the graph of f of theta. Okay, so looking at this picture, how long does it take to complete one cycle? Remember that we can measure period from crest to crest, from trough to trough, or from the same point to the same point. And if I do that, I go from 0 to pi. Okay. Frequency is 1/, the period. So your frequency here is 1/, pi. That reads like this. I complete one cycle for every pi radians. Can you tell that that's what it's saying? One cycle per pi.
So should it be like pi x if the range would change?
Pi would be your number of x values. Okay, where's our midline here? 3. At y equals 3. That's an actual equation of a line. Midline, y equals 3. And amplitude is distance from midline to peak. So 3 to 6 is going to be 3. Amplitude here is 3. Cool beans? Okay. Moving on. Okay, so on the next one, several periods of this function are shown. Okay, so if I'm going to measure from crest to crest, how long is my period? Pi/2. Pi/2. Which means that my frequency is 1/, pi/2. When I divide by a fraction, that's the same as multiplying by the reciprocal. 1 times 2/, pi. In other words, 2 cycles for every pi radians. Can you see it? If I mark off pi, do I complete 2 cycles? 1, 2. Yes. 2 cycles for every pi radians. Okay. Midline. 1. Y equals 1. Amplitude from 1 to up to 3 for the peak, or from 1 down to -1. Feels like amplitude is 2 here. Okay, example 3, no graph. Now, this is where things get interesting, and this is why I appreciate this resource so much. Okay, listen. It says it has a maximum at the point pi, 8. It has a maximum at pi, 8. The first minimum after reaching this maximum value occurs at 3 pi. Now, that's a halfway point. Okay? What that indicates is that it's gone from peak to minimum. We always measure period by going peak to peak. So if this has gone from peak at pi to minimum at 3 pi, That's halfway through the period. So it's going to have to come back up to what? 1 to 3 to 5 pi, right? Are you all seeing that? It takes 2 pi to get from pi down to 3 pi. It takes another 2 pi to get back up to its peak. Are y'all following that? Okay, so its period is actually going to be double the distance between the peak, the maximum, and the minimum. So how I calculated period here is I did 3 pi minus pi, which gave me 2 pi times 2, because I know I need 2 lengths. So I got my period to be 4 pi. Are y'all seeing that work? You're going to have to double the distance between maximum and minimum. Because the distance between, I'm seeing bad eyebrows here. Y'all are looking confused. Look at me. The distance between the maximum and the minimum.
Did you say dad eyebrows?
Bad eyebrows, like this. That means I don't get it. The distance between maximum and minimum is only halfway. A whole max and max would be the period. So I've got to double the distance to get to the next one. Okay. Frequency is going to be 1 over 4 pi. It's going to complete one cycle every 4 pi radians. Can you tell? Okay. Now, midline. We know that our, what happened? So the period, because it's starting at pi and going to 5 pi, then the distance between them would be 4 pi. Good question. The midline is going to be located halfway between the maximum, which is at 8, and the minimum, which is at -2. So what I usually do is I subtract. I say, what is 8 minus -2? Now, this gives me amplitude. This gives me the height between the two, right? 8 minus -2 divided by 2, that gives me a 10 over 2. That means I'm talking about the distance from the midline to the peak being 5. I'm splitting the difference between max and minimum. Now, my amplitude maximum, or my maximum of my function, is at 8. Amplitude is 5. So 8 minus 5 puts my midline at y equals 3. Whoa, Pete. Okay, that's why I'm telling you, like, even though we already covered this topic, we didn't cover this topic. Are you seeing it? Do you understand where these numbers are coming from? Okay, so amplitude, I take peak minus peak and split the difference because it measures peak to midline. For the midline, I subtract the amplitude from the maximum. Okay, so let's go to the next page here. This, I think, is our last bit of notes. This is that clock thing on the wall again. Okay, you've already seen this problem, but we're now going to look at it in terms of frequency, midline, amplitude, that kind of stuff. Okay, so we've got a large clock mounted to a vertical wall. Clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. At time t equals 0, the minute hand is pointed directly up at the 12. However, the clock's not working properly, and the minute hand is moving twice as fast as it should. So a period is going to be how long? 30 minutes? Are we talking about the minute hand? So our period here is going to be 30 minutes. 30 minutes. What's the frequency? 1 cycle for every 30 minutes. 1 cycle for 30 minutes. Good. Okay. Amplitude. Based on what? 8? How do you know? It's the radius of the clock, right? 8 is the radius of the clock. It's the distance from the midline to the peak. So 8 for your amplitude. And where is the midline located? Say it again. Yeah. Midline's going to be at 120 because the center of the clock is 120 inches directly above the floor. So midline is going to be at y equals 120. 120. Midline is at 120. Because the center of the clock, so right here, center of the clock height is 120. Okay? So, when we're at point F, that means it's at 12 o'clock, right? So my F coordinates are going to be 0, comma, and at 12 o'clock, we're at 128 because my amplitude is 8. So by the time it gets to G, how much time has passed? But it feels like it's not 15. It's 7.5 because remember, a period is 30 minutes. So by the time it gets to G, it's only gone for 7.5 minutes, but it's located on level with the floor, right, on that 120. By the time it gets down to J, it's closer to the floor. It's only 112 away. And at J, it's gone through a half cycle, which is 15 minutes. We feeling better about this? For K, it's swung back up 22.5 minutes, comma, back at the midline. And for P, rotated all the way back to a top, period is 30 minutes, and it's now located at 128. Are those feet? Inches? Inches. Good. It's not like a tower. Okay, so find the two intervals for which the graph of H is both decreasing and concave up. Decreasing and concave up like a cup. G to J. And?
6.
F to J.
Is it F to G?
Decreasing and concave up.
G to J, isn't it increasing?
I think it's decreasing here for sure.
Oh, wait, I wasn't at because it goes into never mind. Like the root of change, that's what I was thinking.
I don't find another one where it's concave up. Not that's marked. I would say from here to here. But I'm not seeing another concave up.
All right, that's what we're going.
Okay.
Scratch down.
Okay. Any questions here, guys? Okay, so you have homework that goes specifically with these notes. Okay, you should be able to knock it out pretty quickly. But those two, like I'm given 2 points and I have to find amplitude and midline and that stuff. We haven't looked at it like that before. So I want you to get that practice before we move on. Okay, if you need help, come see me. Otherwise, you're on your own. You got this.
Our first